Okay, I want to I want to kind of go over um, this rotary converter again, and I kind of want to show the similarities between the rotary converter design and Tesla's two-phase AC generator, synchronous output generator. Let's see if I can get a shot of it here. This is Tesla's AC two-phase AC generator right here. It's got four slip rings. It's got two outer coils and it's got two inner coils on the rotor, and two coils on the outside stator, and it works just like this rotary converter down here, pretty much, except my rotary converter has a commutator, uh, and it has only two slip rings over here. But this one doesn't have a commutator, and I'm pretty sure the way it works is you just hook up the outer coils to some sort of battery, and then as you start to crank the generator or turn the generator, then you get the two-phase AC output. But what what I wanted to kind of go over was uh, back in the times when Tesla, like, this is back before 1900. This is in like at 90 something, or 1882 is when he thought of this machine, and he built it like in the early 1890s or something like that. And back then people didn't think that you could control AC power, or the AC alternating current would race out of control or was uncontrollable. But with a motor or generator like that one, like Tesla's, or a rotary converter, you can easily control the AC output by means of controlling the DC input. Now, I have this golf cart battery charger here instead of batteries for this example, and I'm going to be using my Variac to control the battery power to the rotary converter. But instead of having this as the battery power, I'm just doing this because it's a little bit difficult to kind of hook up all the batteries. And then what I was thinking is you could hook up what is called a shunt wound motor controller and use it to control the DC power to the outer coils and control the speed of the motor, basically, because that's how electric shunt motor works. It doesn't have electricity just go through a commutator and go through the outer coils and the commutator and the inner stator coils from the same power source. You have a different battery power source for the outer coils, and you make them permanent magnets, and then you turn the motor with a different battery source. So all in all, you're basically using battery power with shunt motor controller system to control the AC output of this machine right here. And you can easily do it by controlling the battery power like this. So as I turn the knob and give it more DC power, and you can see shows the amps over here. And if you start to give it too much, then it starts to bob up and down. If you give it too little, it starts to bob up and down. So you want to keep it right in there in that stable area. So that's how I can control that. Or if I had too much drag, I could always just increase the current or decrease the current. So this gives me complete control over the battery power going into this, but this is not what I would use for this example. I would actually want to use batteries with a shunt motor controller to control this, but I just don't have that set up right now. I don't even know if I have all the equipment to get to work. But once you have controlled AC output power, then you could use a Variac of some sort to control the AC voltage to whatever it is you're powering with this unit. So you not only would have power over how much DC power you're using and how much you consume by the turn of a knob, but you would also be able to control your AC voltage by the turn of a knob. And so this is really a great example of how you can actually control a DC to AC power system with nothing but, throttle, um, knobs, those voltage sensors for speed control, shunt motor controllers, or those little wipers that they use, like volume knobs for stereos and stuff. Those old school volume knobs that click on and you turn. They have little wipers on them that act as controlled resistors for the amount of current that you have flowing. So pretty interesting how all this stuff is actually out there and available, but nobody seems to use this kind of a power set. All I've been doing is been powering my little lamps that I have here, like this one. I'm using the high voltage microwave oven transformer back there that's being powered by the converter, and I have the wires running through the ground like I did before. This is the lamp that I used for my ground rod demonstration here. So anyway, I'll go ahead and stop it here, but very interesting how you can build a system, just like kind of how Tesla envisioned back in the day, and build yourself an actual uh, controlled power system. Very cool. So we'll go ahead and stop it here.